Buried beneath the cold stones of Shanidar cave in Iraq and the windswept plains of southern Russia, two ancient men lie silent, their stories told not through words but through the bones they left behind. Their arms, one crushed and wasted, the other massive and overbuilt, speak of pain, adaptation, and power. Shanidar I and the Khvalynsk Neanderthal may have lived 1,000 miles apart, but their skeletons bear witness to a shared experience, the life of a hunter whose very survival depended on strength, skill, and perhaps most critically the support of others. Their asymmetrical limbs are more than just quirks of anatomy. They are windows into the muscle-driven world of the Neanderthal, a world shaped by high testosterone, hard labor, and the ceaseless demands of survival in Ice Age Eurasia. But what does it mean when a Neanderthal's arm grows grotesquely stronger on one side, or when another lives for years with a shattered limb? These are not just medical curiosities. They are clues. They reveal which hand gripped the spear, which side bore the strain of butchering carcasses or chipping flint. They hint at behaviors so repetitive, so vital, that they rewrote the very structure of the body. And in those healed fractures, in the bones that mended long after the trauma, we glimpse something even more astonishing. A Neanderthal society willing to care for the injured, to protect the vulnerable, and to endure as a community. Let us begin with the man whose injuries changed everything, Shanidar I. Shanidar I was discovered in the 1950s in a cave deep within Iraqi Kurdistan. He lived around 45,000 to 50,000 years ago and died in his mid-40s, an exceptional age for a Pleistocene hominin. But it is his left arm that commands attention. Crushed either in early life or by trauma, his entire left limb, from the upper arm to the forearm, was atrophied, twisted, and ultimately amputated at the elbow. The bones show no signs of recent trauma, which means the injury happened long before his death. Remarkably, it had healed. Shanidar I lived on for years, possibly decades, without the use of one arm. The implications of this are extraordinary. In a world where daily life involved hauling carcasses, building shelters, flint knapping, and close-range hunting with spears, the loss of an arm should have been a death sentence. Yet Shanidar I survived. He may have been blind in one eye and suffered from partial deafness as well. These cumulative disabilities suggest not only resilience, but assistance. Someone must have helped him hunt, eat, and move across dangerous terrain. He wasn't left behind. His people took care of him. But while his left arm wasted away, his right arm was overdeveloped, particularly in the shoulder and upper arm. This is a textbook case of compensatory hypertrophy. Shanidar I used his remaining arm for nearly all tasks, leading to exceptional muscular development and dense bone formation. In the right humerus, the areas where muscle attaches are enlarged, especially the deltoid tuberosity and the area for the pectoralis major, indicating years of heavy use. This pronounced asymmetry is not unique to Shanidar I, but is amplified by his disability. If Shanidar I represents adaptation through loss, then the Khvalynsk Neanderthal, a robust male from southern Russia, is the mirror image, a man forged in the crucible of constant exertion. His fossil, rediscovered after decades in obscurity, includes a remarkably massive right humerus that dwarfs the left in both thickness and muscle attachment points. It's this grotesque strength that earned him the nickname Popeye Neanderthal. A recent paper concluded that the remains of this Neanderthal show that Neanderthal men were heavily pumped up on male hormones, having a hormonal state that is very different from what humans have today. The study, which was published in the journal Archaeology, Ethnology and Anthropology of Eurasia, says that Neanderthal men probably became very strong through their genes, their habits, and the food they ate. Maria Mednikova, who was in charge of the project, concluded that Neanderthal men hunted in the extreme, which helped build up one arm. A professor at the Russian Academy of Sciences Institute of Archaeology, Mednikova, said the most common way to kill an animal was to attack it directly. Neanderthal males would not shoot their prey, like mammoths, with a bow and arrow from a distance. Instead, they would meet the animals head-on and stab them with long, thick spears. Neanderthal women were also not gentle beings. Mednikova and her team think that, compared to anatomically modern humans, both male and female Neanderthals had a larger muscle mass and experienced a higher loading on the upper extremity than did Homo sapiens. Moreover, they differed from modern humans by a greater functional difference between the sexes in the use of the right arm. The study found that Neanderthal men had right arms that looked like Popeyes, while Neanderthal women had arms that were more even and not nearly as strong. The humerus is the long bone that goes from the shoulder to the elbow. Mednikova and her team looked at a fossil of what they think was a male Neanderthal who lived in what is now Khvalynsk, Russia, about 100,000 years ago. Computerized tomography, X-rays and other tests were done on the bone. The fossil has a strange mix of thickened walls and small bone marrow region cavities. Scientists say this means intense mineralization created the strong, stable bone structure, while much less mineralization was needed for the inner narrowness, because the shaft design was stronger. The mix is strange because Neanderthals demonstrate a markedly androgenic constitution, which means they had a lot of steroids. But these hormones can also make bones less mineralized. So the researchers say Neanderthals were characterized not only by peculiar biomechanical adaptations, but also by a specific hormonal condition which has no close parallels among modern human hormonal conditions, either normal or pathological. Neanderthals who lived in cold northern climates and ate mostly meat may have developed this condition over time. Mednikova said that there weren't many edible plants in colder places and that the growing season wasn't long. They became specialized hunters who hunted terrestrial herbivores, like mammoths and forest deer, because they didn't have much fruit and veggies. Then they ate nearly exclusively of proteins and lipids, which must have had an effect on their bones and hormones. Unlike Shanidar 1, this Neanderthal doesn't show signs of trauma. Instead, his right arm was shaped by repetitive one-sided labor over many years. This is consistent with a lifestyle of tool use, hide scraping, spear thrusting, and other high-force tasks. Flint tools from the Mousterian culture associated with Neanderthals required immense manual effort. Scraping hides, for example, uses an inward motion that places strain on the dominant arm while stabilizing with the weaker one. Doing this every day from adolescence into adulthood would naturally result in extreme asymmetry. The Khvalynsk Neanderthal likely represents a more generalized condition seen across Neanderthal populations. In most individuals, the right arm was 10 to 30% stronger than the left, a level of asymmetry rarely seen in modern humans, even among manual laborers. In Khvalynsk, however, this reached an unprecedented level. His right arm wasn't just stronger, it was grotesquely overbuilt, with bone density and volume more typical of elite athletes or pathological cases of hypertrophy. The asymmetry seen in both Shanidar 1 and Khvalynsk is rooted in a fascinating question. Were Neanderthals right-handed? The answer is yes, overwhelmingly so. Analysis of dental microwear patterns from multiple Neanderthal sites reveals that they gripped materials with their teeth and scraped with tools in the same direction, consistent with right-hand dominance. Studies suggest that up to 88% of Neanderthals were right-handed, a proportion nearly identical to that seen in modern humans. Right-handedness is associated with left-brain dominance, which is linked to language and complex tool use. This raises intriguing questions about Neanderthal cognition. If they shared our handedness patterns and neural lateralization, could they also have shared the neurological capacity for language, symbolic thought, and sophisticated planning? The pronounced asymmetry in their arms was likely not just a result of genetics, but of behavioral conditioning. The more they used one arm for specific tasks, the more it developed. Over time, this repetitive, high-intensity labor altered their musculoskeletal anatomy. Flint knapping, hunting, butchering, and hide preparation weren't just daily chores, they were physically transformative. But behavior alone doesn't explain the size and strength of Neanderthal limbs. Genetics, particularly gene expression related to testosterone and muscle development, played a critical role. Recent epigenetic studies, such as those using DNA methylation maps, have shown that Neanderthals had increased expression of genes related to muscle growth, bone density, and androgen receptors. These include several genes which mediate the effects of testosterone. In simple terms, Neanderthals were wired for strength. Their skeletal robusticity, thick bones, prominent muscle attachment points, and dense cortical bone reflects not only behavior, but a hormonal profile rich in testosterone, especially during adolescence and early adulthood. High testosterone levels would have promoted aggressive behavior and territoriality, enhanced muscle mass and bone growth, increased physical endurance and drive, and even influenced mating strategies and group dynamics. The combination of hard labor and high testosterone created a feedback loop. Their bodies grew stronger in response to behavior, but their genes gave them a head start. In the case of Khvalynsk, this likely meant natural hypertrophy supercharged by constant stress on the dominant limb. The result? A Popeye-sized arm that was not a deformity, but a badge of evolutionary specialization. While hypertrophied arms reveal the demands of daily life, broken arms, like those seen in Shanidar 1 and others, reveal the depth of Neanderthal social structure. Across many Neanderthal sites we find bones that were broken and healed, ribs, femurs, skulls, and especially arms. The high frequency of upper limb trauma, often from blunt force, is consistent with close-range hunting, where spears were thrust into large prey like bison and reindeer at high risk to the hunter. It may also reflect interpersonal violence, accidents, or predator attacks. Prehistoric combat leaves behind clear evidence. A wooden club is an effective means to injure. Clubs are swift, powerful, and precise weapons, hence Neanderthal skull and arm trauma is common. Indeed, one unmistakable signature of conflict is a parry fracture, which is a break in the lower arm caused by warding off attacks. Neanderthals exhibit a high rate of broken arms. Trauma and mortality were especially common among young Neanderthal males. While it is possible that many of the injuries were sustained during hunting, the patterns are also consistent with those that are anticipated for a population that was involved in intertribal warfare. What's remarkable is that many of these injuries healed, suggesting that Neanderthals tended to the wounded, protected the incapacitated, and provided food and shelter for those who could not contribute physically. In modern primates, similar behavior is rare. Among chimpanzees and gorillas, injured individuals are often left behind or become easy prey. Neanderthals, by contrast, may have possessed a form of early empathy or social cohesion. Shanidar 1's crushed arm didn't just heal, it told a story of companionship, of a society that saw value beyond utility. This challenges the outdated image of Neanderthals as brutish and solitary. Their bones suggest otherwise. They were tough, yes, but they were also tender. What do we make of this dual portrait? A one-armed man who lived on, and a warrior with a single monstrous limb? Together, Shanidar 1 and the Khvalynsk Neanderthal offer a spectrum of adaptation. One compensated for loss, the other maximized strength. One teaches us about care and cooperation, the other about raw power and relentless labor. Both show that Neanderthals were intensely physical creatures, shaped by forces both within and without, the genes that built their bodies, the tools that hardened their hands, and the communities that bound them together. They left no words, but in the curvature of a bone or the angle of a healed fracture, they spoke volumes. Their story is still unfolding, one arm at a time. Thank you for watching, and let us know what you think in the comments. Also, please like and subscribe.